Hello, Wayland Middle School's Mr. Farley here, ready to give you a couple more problems here about simplifying using the rules of exponents. All right, so let's get this going. Should be pretty good. These are a little bit stepped up a little bit more than the ones we were just working on in class, but this should help you out. All right, so here's the first one that we're going to do. It's we're going to multiply, and I'm hoping everyone remembers the first rules for exponents that we've talked about. All right. We were saying that when the bases are the same, all right, and we are multiplying, then you simply add the exponents. That's all you need to do. However, this problem here has a couple of coefficients in front of these. Uh, I like to just take care of those right away. As long as everything is being multiplied, which is exactly what's happening here, order doesn't matter because of the commutative properties. So we can just go 12 times 2, take care of that to get 24. When I multiply an m squared, I'm looking for any other bases of m, and I don't have any. So I'm just going to rewrite m squared as m squared. And now I'm multiplying, and I do see bases of n's here. So an n to the 6th times an n to the 4th would give me an n to the 10th. So just a little bit different with coefficients. Make sure you multiply, get those things going together, 12 times 2 to get our 24, and then just follow using the rules of exponents that we have been doing in all of the other problems we've been working on the last couple days. Let's try a second one. Second problem that we're going to try right here. This one looks a little more complicated, but I don't think it's really that big of a deal. You guys can handle it. I'm going to, I hope you're noticing a negative 4a outside parentheses, and then there's a subtraction sign inside. Looks to me like this is perfect for distributive property. All right, so let's get ready to distribute that through. Negative 4a times a squared b. That's what I have to do first. Let's do the same thing. Keep the coefficient. I have a base of a times a base of a right here, so a times a squared would be a to the 3rd. Remember, there's a little magic 1 right there. Don't forget. That's important. And this b is just coming along for the ride, times b. Nothing changes. Nothing's being multiplied with a base of b, so we just bring it along. Next door, I come over here. Let's do the same thing. A negative 4 times a negative 5. I don't forget. Switch that sign, okay? It's a positive 20. And then an a to the 1st times an a to the 3rd is a to the 4th. And just like the last time, the base of b, nothing is being multiplied. That would change it. So I'm just carrying it along for the ride. This here is the simplified expression to what we have here originally. And we did that just by using the distributive property. Okay, sometimes you'll come across problems where after you distribute, you might notice some like terms. In this case, we don't have like terms. And just a little reminder to everyone, in order for like terms to be like terms, you need the same variable with the same exponent. Okay, so I agree, I have variables of a's and variables of b's, but if you notice, the exponents do not match. All right, therefore, these are not like terms. Okay, and one more to take a look at. Very good one here. This one here has a couple rules of exponents going on. I want you to bring your eyes over here to the second part of the problem. Please recognize I have a power to power situation going here. That's a second rule of exponents that you were practicing. So what I'm going to do is rewrite everything I see right now, except this part here. Let's check it out. Remember, this power of 3 goes to each part of the base, okay? So this means 2 to the 3rd power. 2 to the 3rd power means 2 times 2 times 2, which is 8. X to the 1st, you put a little magic 1 there. X to the 1st to the 3rd power, you guys know, is x to the 3rd. And then y to the second raised to the third power is going to be y to the sixth. Now I'd like you to stop, take a deep breath, and take a look at what we have left. Someone might think we're done, but check to see if we have like terms. And when I look here, these are indeed like terms. I have the same variables with the same exponent. You notice x to the third and an x to the third, a y to the sixth and a y to the sixth. These are like terms. So I can just do 4x to the third y to the sixth minus 8x to the third y to the sixth. And if I do that, I end up with negative 4x to the third y to the sixth. That is the simplified form of this expression right here. So as usual, kids, if you have questions, please seek out Mr. Robinette or myself. We will be there to lend a hand. Hope you enjoyed another award-winning video here. It's amazing how many of these we've had this year, but hopefully you feel a little bit better working with rules of exponents on a couple of these that were just a little bit more challenging. Hope you guys have a great day. Take care.